Well, that was weird. This might be a bit of a slightly weird sound. It's live. Seconds. Is it working? Is it working? That was a bit weird. YouTube crashed out there for a second. Can you hear me? Yeah. For the audio only people, I'm so sorry that you end up starting every episode with me going, oh, "Can you hear me?" But such is life, and the way that this podcast is created and curated, it wouldn't exist any other way. I think that's working now. Anyway, good. It's saying 34 seconds in. Everyone's saying no sound. I can see sound coming through. Should be working. Everyone's moaning about the lack of sound. It's 11. It's jumped back to 11 seconds in. Stream's being weird. Yeah, good. I got a yay, which means people can hear me. Good, marvellous. Okay, right. It's episode 167. Why do crossing noses crack? Actually, it's not just the noses. This should have been more appropriately named Why do crossings crack? But, and we're going to explain what on earth a crossing nose is. Sorry, I don't know why this stream started so weirdly, but hopefully that won't break it for the post-record. In any case, we have to... you know what? Let's leave the mouse in here for now. Of course, episode 167, we have to shout out to the old-fashioned tops, first-generation tops, DMU, the class 167. Here it is, looking weird. It's a weird little guy here. It's a class 108 in modern tops. Oh, I've managed to cut or ulcerate the top of my tongue, which is not great when I have to talk. It's my horrible, messy, sharp teeth. Anyway, have beer. Yes, everyone agreed, have beer. Anyway, yes, good. Episode 167. Here is a tops, pre-tops, or old tops classified class 167. What a shambles of a vehicle. No, we're here, of course. Yeah, look, it's me as a GIF. We're here to talk about Colton Junction, of course. So, without further ado, I mean, amongst other things, it's not just Colton Junction, but yes, Colton Junction has been vandalised by a train. How rude of the train. Let us... just some weird stuff blowing across the desk. How strange. Right, let's get on with it. Everyone, welcome to tonight's Rail Natter. And as the Intercity 225 fades away, Tim Bounds asked me to do the like poll on live streams to up interactions. What is that? I don't know what that is. We must... first of all, quick content warning. There will be descriptions and images from rail crashes in here, either inadvertently in one of the documents we're going to look through, or the fact that I've put some big ones on the screen. Yes. So take care. But first, with that warning to one side, we must start with the news. Actually, it's a very brief bit of news because we're doing a proper news episode next week. Spoiler alert. But yes, LNER. Weirdly, LNER deleted this tweet after. Why did they? Anyone at LNER? Why did you delete this tweet? What happened? Yeah, a strange one. Anyway, there's a crossing cracked, and this created discourse because obviously. Someone who I have no problem calling a Nazi because he literally appeared at the Nazi conference. Darren Grimes did some tweeting about it and generally got angry. And also some other people got upset, well actually just a couple of people, got upset that I was calling out the fact that the manufacturers use a certain type of design in their construction of their crossings, because this is a monoblock cast crossing that we're looking at here that's been cracked. And underneath it you can see the sleeper is disintegrated. Anyway, so this is interesting. I thought, oh, you know what, it's topical and it gives me a chance to talk about P-Way a bit. So why not do an episode? So yeah, my baby gets done wrong because this is Colton Junction, and I was thinking, I hope it's one of the approach crossovers. Please let it not be my lovely equal splits. As we'll soon see, I'm afraid it's one of the beautiful parts of the crossing. Anyway, this little shitweasel decided to step in. Here's Darren Grimes. Wasted an entire day travelling because of some tiny crack on the track that Network Rail are looking at overnight. I mean, honestly, this country used to rule the world. Now we fall apart over a sodding chip on a rail track. There's a lot to unpick there, and I intend not to dwell on it. But Darren Grimes, just as an FYI, when rails crack, as indeed this one, you can see this rail here, of which bits of are now in the National Railway Museum. This is the rail from Hatfield. This is 35 metres of rail that shattered into 200 to 300 pieces, and yes, derailed a train and killed quite a lot of people. So we take cracks very seriously on the railway. So, yes, don't just shut up, Darren. Just shut up, you little pipsqueak. Anyway, on that cheery note, we need to look at this crack again. Let's get my little face up in the corner. Hello, it's me up in the corner. It's big face. Look, I'm looking haggard for various reasons, including lack of sleep. So here it is. Here is a crossing, as you can see. In fact, let's get the old pen up, shall we? Yeah, pen, go. Yeah, you can see there's a crack. There's a crack here, and it goes up here, and it kind of goes through here, and it's gone through here, through one of the checks, and then through here, and then through the flangeway, and then back down into here, and then out at the bottom of this scallop bit. And you can see also that the bearer underneath here, this bearer has totally disintegrated as well. There is one pandrel housing, there's the other pandrel housing, and the bearer itself is just disintegrated to bits, which makes this a real pain to deal with because you have to reinstall what will be a long bearer, so that's a really annoying faffy job. Yeah, not good. And you can see a chunk has chipped out here, and another chunk has chipped out here. It's just not in a very healthy state. Bad things have happened here, and we should try and understand. We should attempt to understand what bad things have happened here. Yeah, what bad things? Well, we're going to unpick them. So, first of all, where was the break? Well, it was in the cast monoblock crossing of a part of Colton Junction. But thanks to David Horan, we know which part of Colton Junction. Well, thanks to David Horan, MD of LNER, and some other photographs that got sent around, that kind of got passed around on Twitter. We can tell you exactly where it is. So 2295 Bravo points. As David points out, it's where the down main crosses the up Normanton. Is the red box in the picture. So if we zoom in, this is one of those weird situations where, thanks to the switch diamonds, again, we'll explain what this is, we have a situation where we have a Charlie points under the same number. So we have Alpha points, Bravo points, and Charlie points of 2295, as we might call this bit. We might call this 2295s, or 2295 Alpha, Bravo, Charlie. Anyway, Bravo is this bit. You think, well, what's this bit then? Okay, there's a set of points here, but this isn't a crossover, even though it's marked as that in the 5 mile diagram here. Actually, this is something rather different, which we'll look at in a little more detail. This picture was very useful, thanks to whoever tweeted this out to me. But you can see that this is a good picture for a variety of reasons. Firstly, I can identify where, in quite a busy layout, there's quite a few tracks here, I can identify where it is. So firstly, we can see that there is a big mast there. There's an access road that's a little bit below the railway, which tells me which direction this photo is facing. So this photo is facing, it is facing east, yes. And that allows me to know which orientation we're looking at as well, because there's just one track here, plain line, single track, rather than multiple tracks that there would be if it was facing the other way. I know this area rather well, as you know, because this is one of my sites of pilgrimage. You can see a bit of bearer here. You can see the bearer is completely split right the way through from the hammer effect of this failure. This is a mess. There's bits of... It's just not gone well. It has not gone well at all. So this helps me to identify where the failure is. And we can have a little look. Because here's me in a 225 racing towards that precise location. There's Colton Junction in the distance. Here we go. I will have a look at your chat in a minute. So here we go. And there it is. The failed crossing. You can see it there. That's the bit that's failed. So the failure has happened here. Smashing up one of these bearers here. So you have to replace a bearer that goes from here all the way through to here, which is annoying because getting it in underneath here is very difficult. That's the sort of situation where you're probably going to take out a few sleepers from here, prop this, and then slide the long bearer in underneath. Might be one way to do it. You might shuffle a load of these. To be honest, I don't think you would. One of the other ways you might have done it in the olden days is shuffle a bunch of these bearers up, shuffle them all up here, and then actually rotate this one round, and then so it's this way, and then pick it up. But I don't think they're going to do that. I think they probably will possibly just lift a few sleepers out here, dig out the ballast, pull the bearer out, put it back in, put the sleepers in, fresh ballast, tamp it up. Not good. Right. While we're looking at this, I'm going to answer a few of your questions. So, right, I can put a poll in live chat. Oh, right, yes. Oh, yeah, I know I can put a poll in live chat. I know what I can do, though. Wait a minute. I can do this. Add a poll. It's funny it says add a Q&A. It's like, right, I'm doing this. Who here has been to Colton Junction? Yeah. No, I don't want to add an option. Maybe. There we are. Ask the community. There we go. I'm doing a poll. Fine. I'm doing a poll. Lovely. That's really good for the audio-only people. They're really buying into that content. Ailey hates how the DFT want to get rid of the Wi-Fi stories broken by Walmart. Yes, that's annoying. It's rare that he gets a W these days, to be honest. But no, have no interest in Walmart because he has outed himself as really rather unpleasant. Anyway, right, let's go down here. Fine. Yes, do take crack seriously. Yeah, last week's episode is a good example. Well, exactly, we did an episode last week, didn't we, about why cracks are important. We looked at joint failing and the problems. Materials crack, they age, they get used heavily. Correct, Raphael, yes. Gareth, I'm sure you're going to answer this as we progress, but am I right in assuming one break led to another? Yes, correct. Michael C., do you think there will be a formal investigation? Yeah, they probably will, and you'll see why, because Network Rail generally investigates these things to understand why the failure occurred. This costs a lot of money, not just in fixing it, but in delay minutes for services. So, yeah, we're going to go through all that sort of thing. Right, so, can such a crack be detected in advance? Yes, by ultrasonic testing for the most part, but sometimes these things can happen pretty quickly, and ultrasonics don't necessarily work wonderfully in crossing areas, so that it can be missed. This can be missed. It shouldn't be, but it can be. Anyway, let's crack on, shall we? There we go. We're making our way out of Colton Junction. Lovely job. It's a nice bit of railway. You can hear me chatting away to the driver there. I'd hardly recommend getting a cab ride. If ever you can organise one, particularly if you work in the industry, get one sorted. Anyway, and here, of course, is the legendary picture, which is currently my desktop background, usually right in front of me here. And the location of the crack is here. Because you can see where those vehicles were parked. The vehicles are parked there. There's a bit of plain line that you could see in the back of the image there. So the image was looking that way. And that helps me to identify exactly where it is. And it is in the crossing on the approach to the Switch Diamond between where you can see this is the Up Normanton and this is the Down Fast here. There we are. And they cross here in perfect symmetry. Oh, there's some what sounds like child anarchy going on outside. Marvellous. And here is a picture of it having just been installed. A slightly different layout, admittedly. The geometry is basically the same, slightly modified. And this is where that was, a slightly different view. You can see it without OLE, which is a bit weird. But yeah, there you go. And you can also see the bit in the middle that's been kind of half excavated when they built this new formation for the Selby diversion. And you can also see where the old tracks were, which is kind of weird. Can you see it on the old? Yeah, the old tracks have kind of it's disappeared part for two reasons. One, because the OLE's got in there, which kind of hides the fact that the 4-track trackbed used to be there. And two, this has been raised up with ballast so frequently to get the track geometry to decent quality that it's raised way up above where the previous track level was. Anyway, I digress. So, and what's more exciting is, of course, we've got these pictures from of them actually building the thing. Again, it's this crossing here. Here it is. It's this crossing. You can see this is the Switch Diamond here. I'll explain all these terms momentarily, don't worry. And this is what's failed, this bit here. In fact, you can see the slightly different colour from the monoblock crossing. From the original layout here, it would have been a monoblock crossing even back then. Even back then in the late 70s. Anyway, right. Oh yeah, we can do better than that because we can bring bring the drawing up from when this thing was built. Because we're nerds, we can do that sort of thing. So here is a P-way drawing for those of you who've not looked at one before. It is mild chaos. Let's zoom in up here and we can have a look at the numbers. We know it was 2295 Bravo here. There we are. So it's this schematic view of it. Footbridge 35, the legendary Footbridge 35. Where's my OBS gone? And if I go this way, this is what P-way drawings look like. So this is it. This is us going along. There's Footbridge 35 here. And here's the toes of the turnouts, 2 NR60H. This is an H switch. There we go. And there it splits, and you can see the track splitting, and then we hit... Here is a crossing. Here it is. It's a 1 in 21 crossing here. It's a 1 in 21 crossing, so it's not too steep. That will become relevant shortly, but it is not too kind of shallow an angle. 1 in 21 is not bad. And then it hits the switch diamond here, and there's the switch diamond, which is a weird angle, 1 in 17.615. It's a 1 in value, which means every meter you walk... Sorry, to get a meter between the tracks, the difference in position between the tracks, you're required to walk 17.615 meters in either direction. Anyway, and then then those rails split apart, and then you've got the 2 separate formations here, and it's all fine and marvellous and good. And you can see the slight change in geometry from the original. So they did slightly change the geometry of the new layout compared to the old layout, which is the one underneath, which had been basically replaced in bits over the years. Anyway, fantastic bit of... originally it was laid in Pan 6 timber and all sorts. Anyway, fantastic bit of engineering, resilient engineering that we've replicated because it works so well. Anyway, there's the drawing. Fine. Let us continue, so you can see where the problem was. Oh, and by the way, if you want to go back at this is the wrong order. I should put that in fact. If you want to learn more about Colton Junction and Selby diversion, obviously go back to episode 84, and there's an episode all about the history of the Selby diversion in there. Let's answer the question, what is a crossing, first, though. Let's do it. Like Spike for the Nerdy Diagram asks Adam Evans. Yeah, indeed. Nobody is... a minority of you have visited Colton Junction. 12% of you have possibly visited Colton Junction. Very nice. At some point, we'll do a RailNatter pilgrimage to Footbridge 35, right? What is a crossing? Well, okay, I'm about to filch some slides from an old Railways Explained thread, so apologies for that, because it's using Cabin Sketch, not Appleberry, so big branding boo-boo going on here, but there are too many slides for me to go through and change the text of easy access. Anyway, if you want to look at this old thread, look up Railways Explained. There's a good thread from where I kind of was at Scarborough Bridge back in, when was this? March 2020. Hashtag content. Anyway, so I pick up 7 interesting things that are in close proximity that are interesting to look at. We're going to just look at 1 and 4. We're going to start with 4, being these switches and crossings. I've talked about S&C a lot. Plenty of you on here will know what S&C is, but others don't know what S&C is. And so, let's explain what S&C is. Here is some of that. You can see here, here is some S&C. And very simply, S&C is where tracks need to converge and diverge. So if you have... You've got a one track here, you've got another one connecting through. You can see that your sleepers all kind of smooshing together with each other. So actually what we do is, we swap the sleepers with some what we call bearers, that kind of through bearers that connect right the way through. You might, although these days less and less, you might have some extended bearers just to kind of put some equipment on. So then obviously you need to create some space for this is where the crossing comes in, because you need to have a solid piece of metal, but also it needs to have a free flangeway route so the wheels can actually pass through in either direction. So you did flangeway. So you also then, because you've then got gaps, you need to put some check rails in. You put some points operating equipment in to actually move the switch. And then you end up with the switch end and the crossing end. The crossing, in this case, a common crossing, because it's kind of equal either side, common crossing. And that's how you get the switch and crossing unit. There you are, switch and crossing unit. Marvellous. I hope that's nice and clear. There you go. And you have what's called the through route, which can be traversed in either direction. And you've got and when it switches over like that, you've got the turnout route, which can be, in theory, traversed in either direction as well. So there you go. That's a switch and crossing. And we did kind of name switches and crossings by the switch length, which gives us speed, and the crossing angle, which also gives us speed. So the combination of switch length, which we designate with a letter, and crossing angle, which we designate with a number, gives us the speed that you can traverse the turnout route of the S&C. So here's a little stubby B9 1/4. You have a longer H28, which gives you 90 miles an hour. And to get 125 miles an hour for a standard unit, then you require a J switch, a J44.5, unless you do the snazzy Colton Junction thing and do the equal split trick where you bend it over to create that perfect mirror symmetry, 6,000 meter radius, 125 mile an hour curve. Beautiful. So that's a switch and crossing, and here's what a standard. This is a CV either a CV9 1/4, actually with extended bears as well. Look, it's got some extended bears, marvellous. Here's a CV9 1/4 that's at the back of the High Speed Rail College at Doncaster. Standard bit of S&C, and you can see we've got the switch at this end. Here's the switch, lovely. And over here, at the top end here, you've got the crossing. And here it is. Here is the crossing itself. So this specific part here is the nose. In fact, very specifically, there's a line here that we call the nose. And that position is a certain distance back from the if you've got a running edge here, so the position at which the rail runs when it's going on the through route, and a running edge here where the rail runs on the turnout route, you can see they don't quite meet here. In fact, they have a crossing point that's actually a bit further back. So you've got the theoretical nose is here, whereas the actual nose is there, and there's a kind of a set distance between these two. That kind of generally depends on the geometry of the switch. Anyway, this is this is a part fabricated crossing. So it's these bits here are bolted on rather than being part of the metalwork. But this thing is kind of one big solid metal lump, and actually this one has been explosive hardened because you can see it's got a different. It's actually a different crystal structure. The steel is a different structure, a slightly different alloy as well, high manganese content probably. To the kind of the plain line, well, not the plain line, but the normal rails here. So the normal rails here, the gut rails there, the S&C, and you can see there's actually a bimetallic weld here with a different weld material to allow the two to be connected, to be welded together. So there you go. That is a crossing, and here, yeah, there we go. You can see, and in fact, they've drawn. There's like a marked line where the crossing nose is to help the surveyors. That soon gets wiped off. There you go. Fine, lovely. There's a crossing nose. That's what the crossing looks like. And as you can imagine, as trains hit that, trains have to go either way. Kind of either they're going that way or they're going that way. This thing gets a bit of a pounding. In theory, it should never be struck, but it does get struck, and it takes a bit of a pounding. Hence why it's explosive hardened. Where they literally put TNT on it and blow it up to harden and change the crystal structure. So, some more queries and questions coming in. Let's go big face momentarily while I let's see. So, let's see. But Railnatter branded version of that pick as a wallpaper. That's not a bad idea. It can be a Patreon thing. I'll provide that as a download in the Patreon if you're a subscriber. Go to the Discord chat. How is it detected? I presume it's detected because a train went over it and it went bang in reference to that original craft failure. Raphael Nicholas, when was this built again? How often do you replace parts in general? When, if at all, was it last replaced after construction? When was this built again? It was built in 80. That layout was probably laid out in 82. Next question, how often do you replace parts in general? It depends how often they wear out. It might be once a year, might be once every 5 years, could be once every 15 years. It depends on the annual tonnage, speeds. If something's gone wrong, if it's been walloped by something, a dodgy wagon or something. When, if at all, was it last replaced after construction? So I think that layout was replaced in like 2014 or something like that. Possibly it's had some steelwork replaced since then as well, but some of it, get a big replacement like that where the whole thing got renewed, I think that happened quite recently, relatively speaking. The fact that it was still on timbers means that it had only small part steel replacement, I think possibly since installation. Certainly since the 90s. Right, let's go. Mike Waldridge, I always used to think the S&C abbreviation was Signalling and Comms. No, that's S&T, Signalling and Telecoms, S&T. But that's also an outdated thing now because we've split Signalling and Telecoms out really as disciplines because they're quite different. They do different things. It's switches and crossings. S&C is switches and crossings, Mike. Yes, indeed. Why are those bearers before the points on the wrong side for load bearing? Why are those bearers before the points on the wrong side for load bearing? Rat King, I'm not quite sure of your question there. Anyway, right, so let me see. I don't have it on top chat, I've got it on live chat, but I only generally see the ones you at my name in. And what about passenger comfort going through switches? Speed? Well, that speed through those switches is based on understanding of passenger comfort. Is the radius of the switch higher than the equivalent radius of a curve? Nope, we essentially design them. We design the turnout route essentially as if it is. There are some allowances we make in terms of the rates of change at the toes of the cross of the switch. Toes of the switch being these are the toes here. This is the toes. So we make some allowance for rates of change at the toes instantaneously, but no, we design the curvature just as if it's just a curve, So when we're designing the through route, we'll do our design calcs as if the train's just running through it as a piece of plain line, as if it wasn't a switch. Right, anyway, so I digress. The other thing that we need to talk about and define is talk about diamond crossings and talk about other kind of crossings in isolation where there isn't a switch, or perhaps flip the flip side. So that's a crossing as part of a switch and crossing. A switch and crossing. We often call them switches. But let's talk about when two tracks just cross each other without there being a switch. Well, firstly, obviously there's a load of sleepers smooshing into each other, so we replace those with bearers. There we go. And then we have some common crossings, and some obtuse crossings. So there we go. Common crossings, obtuse crossings. That's the two types of crossings generally. There's going to be fixed lumps. There we go. A good example of some is here at Newark Flat Crossing. There you are. There's some nice, lovely set of obtuse crossings. These are not switch downs though. If you have two tracks crossing each other at a very shallow angle, like here, well, firstly we swap out the bearers, and then you actually you basically have two switches facing each other. So you have, there's some point motors, fine, and so you have a train going that way, and then if you flip those the other way, obviously this is a very sketch, really. You can then go through the other way. So you have a switch diamond versus a diamond crossing. These are the two. Diamond crossing, switch diamond. And basically that's two face-to-face switches there. But you will have a crossing. There's a crossing here, and a crossing here as well. And that's what we have in at Colton. And indeed, it's this crossing here that's the one that has failed at Colton Junction. So, let us explore why it's failed, and how do we stop it happening. Indeed, yes. Picture had the bearers on the wrong side. Do you mean the long bearers on the wrong side? Not necessarily. You can have the bearers on either side. Right? What? Rat King. We're going back. Let's have a look at. There we go. What? Bearers. Oh no, these could be either side. This could be. It just depends, because this could be 6 foot mounted. It could be 4 foot mounted. They could extend this way. They could extend this way. It's not wrong. It just depends on site conditions. In this case, they've extended them into the. Well, it's not really a 6 foot. It's like a wide way because they've laid the tracks stupidly. But they've in this case they've got they've made them 6 foot. They've made them 6 foot mounted. But actually, usually you'd have them going this way. So actually, in this case, it's the real physical S&C layout that's wrong, not the not my sketch. Anyway, point made. So that's all that. Let us explore why crossings fail. So this thing up here. Why is it broken? Why has it done this? Why has it done this thing where it's cracked and smashed the bearer to bits? To understand why, we need to open up a standard. It's a pretty good standard, this one. I'm a big fan of this standard. We're going to get the old Control L up, and we're going to... Oh, wait a minute. Close your eyes if you're photosensitive, sorry. This is Sinsin Su's S&C Track Design Good Practice Guide. It's a very... If you're a designer, by the way, hello everyone. If you're a designer, then you should have this standard, and it is a very good standard, and I think this is the latest version. It might have had a slight update since the version I've got here. Anyway, this is December 2016 version, and it's a guidance document. However, there's a lot of very important, useful, and valuable information in here for designing S&C layouts. And it's all about trying to get better performance out of S&C, because it's a key failure mode on the railway. It's a key point of failure because they're very complicated, both in terms of the fact they're an interface of signalling, an interface of telecoms, an interface of EMP, and an interface with track, and also they pound the track bed as well. So there's a lot going on. So it's the standard kind of goes, scope, key principles, fine. It's talking about various bits and pieces that we can avoid. It's also these are the sorts of things that it's good to reference, because they help us to break free of the nonsense that we get told to do as designers, particularly those of you working on the S&C Alliance. Like-for-like renewals, even if updated to current rail sections and/or S&C format, may not meet current network rail objectives for safety and reliability. Also, often you could swap a like-for-like for an upgrade from a 25 to a 40 mile an hour switch and make an enormous difference to the timetable, as we've discussed previously about how to make trains go faster. Anyway, so there's this table 1 here, which gives loads of useful stuff about where the good, neutral, bad in terms of where you actually place S&C in relation to things like cuttings, structures, topography, There's some rules about distances from bridges and speeds. Ideally put S&C in low speed areas because it reduces the consequences of a derailment. S&C is a high risk area in terms of derailment, so you want to ideally put it in slow areas. Discussions about the S&C layout and kind of leads, crossovers, traps, double junctions, scissors, tandems, and then slip switch diamonds. So all the complicated stuff like switch diamonds that you should avoid, and double junctions. So Colton sacrifices a lot in maintainability. Why do I say that? Well, if we jump back to the picture, one of the problems here is that if you look from our bit that's failed to our other crossing up here, this section of plain line track here isn't very long, and it's therefore quite difficult for Tamper to maintain that geometry. So it requires quite careful maintenance to keep this thing running tip top. And particularly in Network Rail world, where maintenance is being squeezed, what is it? Defer, decay, delay is my CP7 motto for what Network Rail has been told to do with its money. So you have to look after this thing, and this is a layout that works very well from a timetabling and a planning perspective. It's beautiful, not least because the crossovers at this end and kind of down this end as well. The crossovers mean that you can have any sort of parallel. See the discussion that we had on the episode about making trains go faster, where we talk about Colton Junction. This is a beautiful layout, but it does require a bit of additional maintenance. It requires a little bit of love and care. Is there another way this could be designed? Not with the current range of switches that we have access to, no. I don't think the J switch is actually out for approval yet within NR60 Mark II. It might be, but I'm not sure it is yet. In any case, no, it'd be very tricky to. You'd have to design this differently, and it would involve a lot longer switches. Let's put it that way. We'll talk about that momentarily, though, Matt. It's a fair question. We'll talk about that shortly. So let's get back to our standard. So there's various bits and pieces, things like geometry and crossover speeds and all different types of the way that you run the switches, and that are fun. Lots of good stuff to think about. Drainage is absolutely key. Access points key. Lighting key. All these kind of useful things to think about. So a very good standard to pick up and rely on. And then there's other stuff as well. Things to think about in terms of other issues, high risk switches. These are some of the things that we'll get to shortly. The reason I've picked up this standard is actually there's loads of other bits and pieces here for us designers. This is lots of useful stuff for us that we live through. 2 leveling, good god. High tonnages, check rails, grinding, and there's some signaling checklist stuff as well to pay attention to. So dealing with dealing with IRJs, fine. All the things that we can do to make the S&C work better from a S&C from a signaling perspective. Now, site investigation. We're going to go through a few key examples. We're going to whiz through a couple of examples. So I said there's some crash imagery. Here's Glasgow 2007, where a train derailed because of high risk S&C failure. So we're going to go through that. This is switchblade failures, where we're going to kind of whiz through this reasonably quickly because this is about switches, and we can kind of move on, but this gives you an idea of some of the analysis that's gone into this standard. So there's a fair amount of thought. There we go. Lots of messy things going on, lots of noise. There's a stock photo of someone being unhappy about noise. Marvellous. Fine. Lots of stuff about RCF. Lots of important things to think about. Gauge widening, fine. More problems. Now here we go. Now we're starting to get into the stuff that's interesting. So we now get into some crossing issues. So significant batter of a part fabricated crossing on a freight route. So here we go. So here's some batter going on. I talked about the nose getting hammered. Well, here's a situation where it is. And you can see the solution is swap it out with a explosive depth hardened cast monoblock Manwars crossing. So that's fine. Here's another one though. So this is the bit that gets interesting for us, folks, because premature failure of crossings located near underbridge with uneven track stiffness, North Somerset Junction. So, underlying issues. We know that the underlying issues potentially at Colton Junction. Well, number one is the potential of, well, actually at Colton it's probably not too bad because they've designed the track bed properly because it's a fairly new bit of railway. But we know that it's more difficult or requires additional care to maintain the track geometry through there because of those kind of short isolated sections of track between the back of the crossing and the back of the crossing and then the switch diamond. So there's a little bit of extra care and maintenance. We can see here though, cracks. So this is an example of the underlying conditions are that there's differential stiffness off the end of a bridge. which is definitely a key thing to think about. Common. It wasn't possible to shift that the obtuse crossing of this double junction. So there are these cast crossings, and they're developing cracks here. You can see them developing cracks, and you can see there's this scalloped foot design here. So if I zoom in on it, you can see there's this sort of scallop shape here. You can see my mouse, can't you? Yeah, you can see there's this scallop shape here, and it's those scallop shapes where these cracks are forming, which is a problem. And if I whiz down to... Okay, we're going to skip through two leveling site issues because we don't care about two leveling. That's a frightening, scary thing. So let's skip that. Getting rid of two leveling, fine. Lovely. Canton curvature. Double slips. Actually, we'll so bear the scallops in mind. So there's an underlying cause, but the scallops meant that you got these cracks. Issues of complex S&C, there you go. So King's Cross, all these double slips at King's Cross that have now been swapped out with lots of nice 14 CVs and an EV. So that was a while back now, wasn't it? This ages this standard from back in 2016, crikey. Switch 053 failures for switches, fine. New switches experiencing failure, accelerated wear of short NR60 switches because the transition geometry wasn't quite right. Fine. Right, we're getting to the bit that's relevant to all of us momentarily. We're getting there, folk. Shearing. Yeah, see all this. See, I talk about failure modes. There are lots and lots of failure modes. Lots and lots of failure modes to think about. So, right, we're in another section here. So, premature failure of sharper angled crossings at higher line speeds and inherent design deficiencies of NR60 crossings. Right, so there's one of the design. So you see, there's lots of problems they've got with this horrible crossing that goes over loads of tracks, which is already that's not a nice thing to maintain geometrically. It's horrible. But there's this thing here. You can see There's a little picture here, and you can see this cracking forming here. I don't know if I can't draw on it, but you can see there's a crack forming here. Again, it's this scalloped edge, this fillet radius here, that's getting this crack forming. Now, not good. So, okay, there's high dynamic forces at wheel area, transfer area, fine, and that's certainly the case at Colton Junction. But the key issue we want to look at here is stress raisers at the casting foot flange area. Cast crossings have been designed with scalloped foot flanges for the past 40 years. At the ends of the scallops are fillets. So these are the scallop, that's a scallop, and this is a fillet. A fillet is where you have you curve the radius between two pointy ends, because obviously metal, you want it to be nice and smooth. So, let's have a look at this. Cast crossing design scallop foot flange. End of the scallops are fillets with small radii which can act as stress raisers. More about that momentarily. Especially under repeated loading. In order to cope with increasing vehicle speeds and traffic tonnage, the design is in need of updating to avoid or at least significantly reduce dynamic stress in such locations. So, casting foot cracking is a common occurrence and accounted for 103 crossing failures in 2012-13. So it's over 100 failures like this a year. That's a lot of failures, and you can see there's just some examples here. There's a crack there at the fillet, another crack at the fillet. There we go. There's a crack at the fillet. You can see here the solution, funnily enough, is to get rid of that scalloping. Do not use a scallop design. Use a design that has a continuous foot flange. Manoir crossings do. So sack off non-manoir crossings. Simple. So sack those off. Use the manoir crossings, which have this continuous foot flange. So far better performance there. It's also it's kind of a tougher beast as well. You improve the bending performance of the crossing that way. And there's other issues as well. Lack of support at the knuckle or at the nose of the obtuse crossing. So the positioning of bearers under crossings appears to be a significant factor. Yes, we know this in the way. So that's where you position the bearers underneath. So actually having a bearer directly underneath the knuckle of this obtuse crossing is a way to maximize its life. So we were talking about a common crossing in our layout, but here's an obtuse crossing where you can see there's a failure. And okay, so that's another thing to think about. And you can see they did some structural analysis about the actual thing and looked at its strength, and actually did some finite element modeling to understand better design of the thing. So you can see there's a lot that goes into these bits of metal. And you can see there the proposal is actually you reduce the bearer spacing through the obtuse crossing and it increases performance, and that's definitely something else that I think is relevant to 2-hour arrangement. And then for the rest of the standard, oh yeah, so the other thing is again, bearer support deficiencies RT60 crossing. So again, you see these scallop feet and bearers that are just not quite, just don't have, the position of the bearers is not well optimized, let's put it that way. And then there's Newark gets its own whole section. And okay, fine. So there's lots of other issues, and I'll whiz through these, and you can see various bits of problems occurring here and there, and lots of various things and challenges, and some of the facts and failure modes here at the end. So you can see the S&C population. There are 20,000 switches and 24,000 crossings across the Network Rail system. It's a decent number, isn't it? Crikey. 20,000 switches, 24,000 crossings. And you can see the different ones by routes there. Obviously these numbers fluctuate a little bit, but by and large they stay pretty much the same. You can see the different crossings at the top and switches at the bottom. So the crossings, you've got, most of them are common, some of them are obtuse, and the occasional compound, which is part of complex S&C. Let's not worry about that. And then so there's crossings by type. There we go. Fine. Crossing angles here. So this is really nice, juicy data if you're a real crossing nerd. So there's quite a few interesting, funny angles here. Blank. I'm not sure about what blank is. Blankety blank. And also the different types of kit as well. So the different, part fabricated or cast monoblock, which is the blue. The blue is the cast monoblock here. So kind of the fully fabricated. Anyway, so there's all sorts of different bits of interesting data there. And switch populations. C switch by far the most common, absolutely. And the B, weirdly, is the second most common. Those will be in depots and things, because we do not like B switches outside of the southern region, who are a bunch of losers because their network is so squished. And then the failure modes. Having a look at different failure modes. So here's the Schedule 8 failures. You see the amount of money being spent due to failures is increasing. Was increasing over this period. It'd be interesting to put this as 10 years ago now, bloody hell. You can see points operating equipment failures, but ironwork failures account for a reasonable amount, and again, we're increasing. They're on the rise, although there's not that many data points. And you can there's lots of there's points operating equipment failure mode. There's lots of different points operating equipment there, and then the crossing failure modes here, you can see Sinsin's added an extra, just added a little graphic on the end there, talking about the type of failure: vertical transverse cracking of the foot in a casting. Yes, so that's our failure we're talking about, and it's 114, and it's 13th on the list, but it's a big performance impact. Yeah, fine. Lots of juicy data in here that you can have a look at. Lots of switch defects as well, and there's just a few more examples, I think. And again, it's casting check flip. So again, stress razors, stress razor cracks. Radius of the crack here. See, and there's just lots more examples. So examples, lots of examples, and then the standard briefing note. Fine. So there you go. That's all that. Good stuff. It's a very useful standard, that one. I recommend everyone gets a copy of it who has used it. Agreed that tamping those type bearers will be painful, Alex, yes. But it's that offset, isn't it? It's like the balance of maintaining of tamping it to line and level, whilst but also the balance of the fact that it's a high impact component that requires that additional track support. So there's definitely a balance to be struck there, and it has to be a back and forth discussion between the maintainer and the installer and the manufacturer as well. But two standards. We're going to jump to another standard here, which is, well, it's not a standard, sorry, it's an inquiry. It's an inquiry here. Now, what is this? Ah, yes, that's right. It's the inquiry into it's the Cohen inquiry, isn't it? It's the Cohen inquiry. Yes, I was just getting the name of the inquiry right. Yes, the Cohen inquiry. And why are we looking at this? Why are we looking at this? Well, because yes, it's famous for probably putting a comet into a water tank and doing repeated loading. Yes, a lot of you are, and here it is. So they also reconstructed Golf Alpha Lima Yankee Papa, which disintegrated. Is that the Italian one that disintegrated over the Med? I think it might be. In any case, messy. The Mayday episode on this is very good. Anyway, bad. This is a comet. Was going to potentially be the absolute pioneer jet aircraft, and because it smashed to bits, Britain was knocked out of that race, and essentially that was the end of our aviation industry. Just immediate demise at that point, really. Kicked off by that point. And yes, it was not. So people often go, oh, but it wasn't the square windows. It wasn't the square windows, because this is a fatigue failure, by the way. The skin of the aircraft was just fractionally too thin to be able to sustain the repeated load cycles, because there was not a proper understanding of the way that repeat load cycles stressed metal. And the Cohen inquiry expanded that understanding greatly, and has had several different impacts on the way that we understand how fatigue works on the railway. One of those things that we understood was, however, and you can see it here, that independent of the underlying issue being the skin, well, a couple of things. Number one, the skin was too thin. Number two, this was supposed to be, the windows were designed to be square to allow the riveting and the gluing to happen easily. Not the windows on the side of the vehicle, by the way. These are aerial windows on the top. Although this one is a side window here. That's the one that failed, and the one they put in the water tank. Anyway, you can see that the failure point is happening at the filleted radius of the window. Now, the reason for that is because it raises the stress. The stresses are raised at that curve fillet. And indeed, you can see here, this is where the crack occurs. There's a filleted radius. Crack forms from there. And so the Cohen inquiry gave us a lot more of an understanding of the impact of stress raising. It's not necessarily that it causes the failure, but if there is an underlying problem like too thin a skin or inadequate support conditions under the crossing nose, then the failure mode you have introduced a failure. You have introduced a point of failure by introducing these stress raisers. It means that the stresses aren't being distributed equally through the cross section. If you get rid of these fillets, if you get rid of that scalloping and have it like the manoir crossing, that nice consistent crossing, you don't create the stress. You don't get the spike in stress. You distribute the stresses better, which means that the crossing can cope under those. It can cope with the underlying condition, at least for longer, if not forever. And yeah, as we point out in the standard, there are lots of pictures of, and indeed these are all. I think all these from Twitter. Oh look, these two identical pictures. These pictures are identical, which is quite funny. Let's not worry about that. But these three are all from Twitter. They're Twitter. All failures from Twitter, and all of them are the same. You can see here. Look. Filleted failure, fillet failure, fillet failure. Stress concentration results in the failure. It triggers the failure. And exactly the same here at Colton Junction. Fillet failure went pop. Not good. Also, you'll notice that the bearer spacings here and here are, I mean, you're right, Alex, better for the tamping, but this is, it just doesn't seem that they're hugely well placed. There's one just under the nose, okay, but has the bearer spacing been optimized for this? Have they done appropriate FEM to actually do, or is it for convenience how they've spaced the bearings? So this is kind of a key point. So get rid of those. Get manoir crossings like these. It will perform better, and they should do that at Colton. They should replace them all with manoir crossings. Make it happen. Now there is one other solution here. It's not slab track. If you've talked about slab track, no, slab track wouldn't necessarily. I mean, you get a load distribution potentially, but not necessarily the solution there. Now, what is the beast mode solution? So, you remember the crossing that I picked up and showed you at, took the photos of and showed you at Doncaster? There it is. There's a nice crossing, and you can see there's the crossing nose close up. It's a fixed solid lump. It's a solid lump of metal, monoblock. And there it is. The alternative solution is a swing nose crossing. Now, this is where you essentially turn the crossing nose into a switch. To all intents and purposes, this bit, the nose, rather than ending here and leaving a big gap here for the flangeway, this thing slides back and forth. It slides back and forth this way or this way, depending on which direction the train's going. It's interlocked into the S&C, and as you can see, the crossing blade, weirdly, nestles in here and provides a nice continuous running edge. Getting rid of the bang, getting rid of that impact force, and reducing the dynamic forces through the crossing. It goes either way. It nestles in the other side if it wants to as well. This one is not. This one is X high speed 1. In fact, I think this might be a photograph of the precise unit. You can see here's the S&C. This is a J switch actually, because it's a 125 mile an hour Actually, it's a 100-mile-an-hour crossover, but it's still I think it's still a J switch. Oh, this tiny thing up here is a swing nose crossing. This is of the switch end. We jump down to the other end, so there's a view of the switch toes. It's not so relevant. Here is that crossing in action. Here you can see it, and you can see here that it's nestled in one side, and there's a nice, consistent, smooth, continuous running edge, getting rid of that hammer effect. Nice, smooth, beautiful. The solution is this: if we want, particularly for Colton Junction, it might be that we actually need to fit switch diamonds to get rid of that impact force. So this is the long term solution. Ledburn Junction did have swing nose crossings in the early 2000s, but they were rail track swing nose crossings, and there was a lug on the swing nose crossing that operated that did the mechanical operation and the detection, the signaling detection, and that lug was a single point of failure that kept breaking. So we don't have any RT60 swing nose crossings. In fact, we don't have any swing nose crossings in operation on Network Rail infrastructure that isn't Network Rail owned High Speed 1 now, because Network Rail, well, they don't own it, but Network Rail are the maintainers of High Speed 1. They should also own it. Sorry, High Speed 1. Diane, I'd like to nick your railway off you and put it back into the ownership of back to Network Rail. Anyway, that's another story. And also, it would stop you charging horrendous, exorbitant track access charges. That means that no one wants to use the Channel Tunnel. Anyway, that's another discussion for another day. Swing nose crossings, that would be a solution. So there are none on Network Rail infrastructure now. There were. Weird enough, there are quite a few RT60 swing nose crossings in operation, unless they've been replaced, on the Northeast Corridor in the US, because Railtrack exported them. Late BR and Railtrack exported them over there. How strange. So there we go. Not sure I've got the angle, the direction of attack, and travel the train right. So in this situation, the train would be going this way, and through here. So the train would be going along this track like that. And then this thing would go the other way, and then the train would go this way through this track, or vice versa. You know, it can go the other way too. Oh, why did that fade? None of my slides ever have fades. That was weird. Anyway, it's because I borrowed those slides from another slide deck. That'll be why. Anyway, Colton Junction, beautiful Colton Junction. Hopefully you have been repaired and are in happy condition once more. We wish not to fail you again. Anyway, there we go. Well, that's it. The crossings. Why do crossings fail? What can we do about it? I hopefully I've answered your questions. It's 1953, which means I'm going to get rid of my face and say, audio-only listeners, it's been a pleasure having you along for the ride. Sorry about the weird start, but hopefully that was reasonably informative. Again, it's probably quite a visual medium, that one, but you can come back and look at the slides later. Shout out to everyone listening in audio only mode. Please do leave a review on Spotify or Google Podcasts or Audible or Apple Podcasts, because all the reviews you leave are I read them. I try to, and also which is useful. I learn from them, and also it helps other people discover it. You know, our lowly little podcast. It's nice to have your support. So leave a like, subscribe on the YouTube, and do the same on whatever podcasting platform you might listen to. Anywho, patreon.com/GarethDennis to support me, and also to get access to the desktop background that someone just requested as well, apparently. I will answer questions momentarily, don't worry. GarethDennis.co.uk/merch for this Teespring merchandise, of which there is plenty, including this oh my goodness, this mug here. Let's just go big face, look at this mug here. Oh, look at that. Look at that lovely Amphitrust mug there with the Amphitrust crest. Oh, glorious. I'm very pleased about that. As you see, this mug is focus. Sanctioned by the Ministry of Information and Communication of the Amphitrust Social Republic. Very pleased, that mug. I'm sorry. Yes, I'm a nerd. Discord is at GarethDennis.uk/Discord, where this chat continues forever. PayPal.me/GarethDennis for loose change and abuse. I've not looked at the PayPal for a while. I'd go in there because you occasionally drop me you wrap a Post-it note around a pound coin and chuck it through my glass, chuck it through into my tomatoes in my greenhouse, and I read those messages and weep. No, thanks for all of your support. Honestly, it means a huge amount to me. Next week, what are we doing next week? Next week is episode 168. It is the news episode that I promised for this week. We'll cover all sorts of bits and pieces. We'll talk a bit about Tesla, but also we'll talk about a few other things as well. There's quite a bit of news going on. The usual managed decline. We'll try not to go through too much of that, but it's always hard to. Yeah. Anyway, let's go big. Let's briefly go big face while we yeah. Let's briefly go big face. So, all right, let's have a look. So, Michael C. Will this type of crossing be used on HS2? Absolutely, it will be. I know for a fact it will be. Gareth asks, "What's the?" Not me, by the way. There's a couple of Gareths who watch the show. This particular one is a big fan. Gareth, I hope you're well, by the way. What's the gradient on that track? Looks rather steep in that image. Oh, HS1. Yes, it is quite steep. You're right. You can see what's quite nice in that picture, actually. If I go back to that picture briefly. Oh, stupid fade. If I go back to that picture, let's get rid of my face. You can see, let's go small face actually. You can see here that the toe, there's the toes, and there's a nice, on the continuous grade, and you can see the vertical curve, so that it's flat grade up to about here, and then there's a vertical curve. If I draw that in plan, that's kind of going like that, and then there'll be a dumbbell, and then there's an obvious vertical curve that does that, and then there'll be another grade like that, going like that. Yeah, and you can see if you kind of were looking this way, you can sort of see, and obviously you want to always position S&C on a single grade like that. You don't want it to be on the curve for hopefully obvious reasons. This is bad. Anyway, yeah, there you go. And what else? What are the questions we got? Good question. Yes, Raphael, does that new nose move on its own, or does it move like a switch? Oh no, it moves like a switch. It's plumbed into the signaling system, so it's interlocked with everything else. Mike Waldridge, really interesting episode. It's also made me realise that my Patreon membership appears to have stopped. Need to get that reinstated. Oh, that's all right, Mike. Don't worry. My poll. Tim says my poll is up to my interactions. I don't know if it has. I've got 70 viewers on here, whereas normally I have about 100. So I'm not sure. Clearly, the people are tired of mine. I need to do a less nerdy episode next week because we've had 3 quite nerdy episodes in a row now. Let's see. Llanfairpwll hoodie. No. Of which he approved greatly. Thanks, Gareth. I'm very, very glad. Yes, Simon is pointing out the steepest parts of HS1 are akin to the Lickey Incline. They are, because high-speed rail... It's stupid that we run any freight on high-speed rail. Sorry, Simon, but it is. It's a high-speed rail line should be a high-speed rail line because it's not good for tonnages. But also, yeah, high-speed line, because it's running the same trains and they don't stop, you can just have high gradients because there's fast trains have loads of momentum. Chris Walford, remember to out my name, by the way, so I can spot questions, because I might have missed something here. Chris Walford, you said earlier that the nose isn't designed to be hit, guide rails, etc., check rails, rather. What's the approximate frequency of the nose getting smacked? How long's a piece of string? I can't really answer that, because it depends on a lot of things, but basically, it's all about it's a very complex series of kind of overlapping variables, because the bogies always hunt, and so it kind of depends on the hunting where in the oscillation that vehicle is as it passes through the crossing as to whether it strikes the nose. But if you think about so many thousand axles, tens, hundreds of thousands of axles go through an S&C unit, then a certain number will hit it or will wallop it in some way. Alex Cusden's here for the P-Way Nerd episodes. Pleasure. More nerdy, please, says Barry Shepherd. Marvellous. Simons F. Kendall, tell that to Deutsche Bahn, who split the Ford train every week. Well, yeah, indeed. Right, anyway, trains per hour times number of axles of each train. Yes, absolutely. Nerdy equals good for us nerds. Yeah, for sure. Right. Anyway, I'm going to drop off because it's 8 p.m. Everyone, it's been an absolute pleasure, as always. Someone said something that I've forgotten, which I should have remembered. Anyway, fine. Another failure caused poor ballast leading to voiding and additional forces and stresses. Yes, absolutely. The ballast condition, well, that's potentially a contributor to what happened at Colton Junction, as we described. The inability to tamp that plain line section around. I'm inclined to believe that'll be what the situation is, because it was the switch diamond rather than the switch and crossing. It was the S&C. It wasn't the equal splits. It was the switch diamond, which is more difficult to tamp and maintain the support conditions for the ballast underneath. So I'm inclined to say that it probably is that, but it's the scallop, the filleting of that crossing, the monoblock crossing, that results in the crack forming there, rather than the loads being distributed and potentially the crossing surviving for longer. So, and surviving until the next tamping cycle, the next maintenance cycle. So, yeah. Oh, anyway, lots and lots and lots of things, lots of other discussions going on, discussions about... you can at me in the Discord if you want to, by the way, if there are questions that you missed. Anyway, right, everyone, I'll see you next week for a news episode. In the meantime, cheerio! Cheerio! by the way, this is the last episode that I'll be recording on the Blue Yeti because we have new technology that's needing to be plumbed in. That's right, we have new technology needing to be plumbed in. And that also includes, that's right, you're getting a little post-credit scene here. It also includes this thing, which has, sliders, which will allow me to have a bit more control, and hopefully I'll be able to control the chat independent so I can mute people through the opening credits. And there's a swear button, so I can I can beep when people swear, like me, because I find swear beeps almost as funny as swearing. Anyway, yeah, there it is. It's the new bit of sound kit that you can't hear because the sound's still on the it's still on the Yeti. Anyway.